and I asked you, what is the domain of g of f of x? So can we find that for starters? Pretty simple. Yep. So what would you do? Take one ear out. What would you do? First things first. I want to find g of f of x. So what would you do? Yep. So we're going to go. Good. F of x is in fact our 2x. And so that's actually now saying wherever x is, go to your g function, and wherever x is, replace it with 2x. So we can say, therefore, g, and this is the same way of writing it as this. So you need to be recognizing that sort of stuff, that would actually be root 2x take 1. Agree? Ooh, a little bit of wind coming up. Take 2, take 2. Yep, that was the wind that put me off, sorry. 2x take 2. Agreed? Now, if I'm asking what is the domain of g of x, g of f of x, what did we recall the domain? Is it too cold? Okay. What is the domain of... Right, it's your x values. So when we see the square root, we are thinking... It cannot, we cannot take the square root of a negative value. So we should be going that 2x take 2 must be greater than or equal to 0. And you can solve that a variety of ways. I'm just going to say pull out a common factor in this case. And when we pull out that common factor, I can now divide by the 2. And so therefore, x has to be greater than or equal to 1, and that is my domain. So I can write that as x is greater than or equal to 1. Finding the range, I would probably suggest that you go your graphic calculator and have a look at the graph of it, a graph of the function. Yeah? And so if we do go and have a look, okay, we go square root 2x take 2. We always go to standard. We can see there, and we're not surprised to see that it's actually gradually increasing. And this point here where it cuts the x-axis, what do we think is going on there? What would that value be without even having to do much?
0.
Where it cuts the x-axis, if it's 0, it'd be here. 1. Yeah. So we can see what would be the range in this case. Can it be less than 0? No, and above, it's just constantly gradually increasing. So we can say that our range would then be y is greater than or equal to 0. Are we happy with that? So there's bits and pieces where, you know, you can say a function is not defined because the domain of one isn't in the other, and it's overcomplicated. I would just say find the function and then actually look at it and suss its domain and range. Okay, and as I said, range is pretty much doing it by looking at the function. It's easy to graph it. In my day, we had to sketch it and everything by hand. Okay, one-to-one functions. I was going to say, can you tell me about those? But I've sort of ruined the surprise a little bit there. So back in the day, we had a test to determine whether something was a function or not, and that was the good old vertical line test. Okay, so if we had something like, let's go, our famous friend, the good old quadratic. Is that a function? Absolutely, because if we were to draw or hold a vertical line anywhere along, it would definitely pass that test, wouldn't it? Passes the vertical line test. But for a function to be a one-to-one function, not only does it have to pass the vertical test, but it also has to pass the horizontal. And so you can see really quickly, if I drew a horizontal line, well, it's got more than one solution. So this is not one-to-one, right? Basically, your good old linear functions would be one-to-one. How could we change a quadratic into being a one-to-one? You with us, Guy? How can I change it into being a one-to-one? Yep.
Repeat at 0. Like inflection point.
so they're saying a horizontal inflection point and touching that, no. So if it was touching the graph like that, that's repeated root, that's still going to have our issue of not passing the horizontal line test. Skyby.
X is equal to 0?
Well, basically you look at it, I get what you're saying. Yeah, you take, so this bit here, if I'm just looking at that bit, so we change its domain. So the light pink one would have been, X could be any value. But if we now change the domain and we just consider this part of the quadratic, that is now considered a one-to-one, because any horizontal line that I draw through will only pass it once. Okay, so not a big deal, but one-to-one functions, just see if it passes the horizontal vertical line test. The reason that we want to be able to talk about one-to-one functions is because we then want to consider the inverses of functions. And the inverses of functions, for it to exist, they have to be a one-to-one function. So can anybody give me a quick demo of how they could easily sketch an inverse of a function? You can say if you didn't get up to that, that's fine.
You draw them.
Yeah?
You draw the inverse, you draw them.
Yeah, but how would I draw the inverse? Yeah?
You flip the X and Y axes around.
Flip the X and Y. Okay, excellent. I love all of this. So a couple of things. One, with the inverse, we flip the X and the Y. And we'll do some of that in a minute. And it's reflected in the line Y equals X. Okay, so now just one little thing. If we can grab our calculators out, please, and I might be telling you to suck eggs here, but so be it. Just so everybody's on the same page. Ooh, jolly good. So you realise that this is a rectangular screen. So if you were to draw a well, let's just have a look. No, we won't do that one. If we were to draw a circle, it would come out looking like an oval. So do you know how you make it be to scale? Well, to make it look like a circle, that would then be when we go shift view window. If you use your initial, that makes your circles look like circles and not ovals, right? Initial. And then you zoom in, zoom out when you're in that mode. Okay, you can see that changes the look of. Sorry. I'm just saying for some things, when you want to see what it looks like nicely and you think, oh, that doesn't actually look like the diagram that I'm expecting, sometimes you have to say like this. You have to zoom out a little bit. And the other one is, if I wanted to actually put in Y equals X so I can see it, and I keep forgetting how to do this. Anyway, you go back over, and if you go to Tool and Style, we never go out of style, you can change that to be like a dotted line, just so you can see where the inverse is going to be. It's handy. You might go, I don't need it, but it's cute. Did we know that? Were there any issues with question 1, 2, or 3? I'll circle around a minute because you're just sort of working through. 3 is pretty good. That's just your horizontal vertical. Can you, those of you who have a notes book or notes page, this is really helpful. So a function is a self-inverse if its inverse equals the original function. So we'll just consider that for a moment. So I've got to say, to keep my sanity, when I see f of x, I basically just replace it with y. So I'm going y equals 2x, take 5. And so now to find my inverse, f to the minus 1, what do we do? What do we do? What do we do? You switch, that's right. So instead of y equals, it's x equals 2y take 5. And now just rearrange to get y by itself. So we can get rid of the take 5. We plus 5. And of course, if this was all the maths that we had to do all the time, we'd love it. To get rid of the times 2, we divide 2. So therefore, f to the minus 1, I should put that out the front. So therefore, f to the minus 1 equals x plus 5 over 2. Oui? But if we look at the question, it's asking us now to take the inverse of that. Does anyone predict what you think is going to happen? Inverse of an inverse.
The original.
Yeah. Is it going to go back to our origi-dig? So, again, for me to be doing this, it's been a long day. I still have to say, okay, y equals x plus 5 over 2. And then we do the switcheroo. So x equals y plus 5 over 2. And you have proven what you have thought. What did you notice? It came back to the original. Huzzah, huzzah. So, yes.
Can you explain what question 5 is on?
We're about to do that.
Okay.
So we've got the gist that any function, so if I had a random, like so, is that 1-to-1? Yep, because it's going to pass the vertical line test, it's going to pass the horizontal. So in other words, each vertical and horizontal line will only cut it once. Shh. I haven't actually given you the function, so how are you meant to draw its inverse? It's if this was nicely, so the x and the y have the same scale, I could now say my inverse function, so we'll call this f of x, its inverse function, what colour shall we go? Blue? I've used pink for the axes. So basically, this one here would go here. They're sort of reflected, so I have to go like that and like that, right? So this would be f to the minus 1. But this value here, let's take this point. If this point was, I don't know, 6, 4, 6, 4. What would the point here be?
4, 6.
4, yeah. That's not really, anyways, that's not very, let's move the point there. That would be 4, 6. So your x and your y's are swapped. Happy with that? Okay, so then we're having a look at question 5. What does that mean? Find all linear functions which are self-inverses. So what does it mean to be a self-inverse? Well, it's the little man or girl or person there. A function is self-inverse if its inverse equals its function. So let's have a think about that. And I think graphically is probably the best way to look at it. So we've got our axes. Axis. Axi. So it cannot just be any old random linear, because if I just went, linear, its inverse is not going to be its original, is it? It's going to be, its inverse is then going to be out like that. So that's no good. Can you think of a straight line that would then be its own inverse? Yep. So they're the same. So what happens if we've got that one? So that would be y equals x. There's another family of. So think about, this is a mirror.
Like if it was like if y equal 2, x equal 2, then we're going to switch
Negative x.
So that's this one, y equals 2, x equals, so 2, 2, 3, 3, 4, 4, minus 2, minus 2. But what I can see from a lot of people too is also what happens if I went like that? So we're looking about linear. Can't be x cubed linear. What if I went like that? Can you see that this section would flip over to that section? Yeah. So that would be its parent through there. What would that one be? at 90 degrees to y equals x.
Negative x.
Y equals y equals negative x. And so what would this one be? This would be y equals negative x, and if I said it's going through here, 6, it would be plus 6. And then I could also have 1 through here, and so on. Yeah? You right, Tom? You listening? So that would mean we've got y equals x is going to be its own self-inverse. And then we've got all of these yellow ones. I should have done the colour code. Oh, let's do the colour code. So we've got y equals x will be its own self-inverse. And then we've also got it's frozen. That's okay. Because I am a tolerant, patient person. It's all good. There we go. We're back. This no technology has really tested my. We're good. Plus anything. And we're going to say plus its y-intercept, which we know as to be C. It can't be anything in front of the minus. Like it can't be a -2 or a -3, because as soon as it does that, then it's slanting, and then it's not going to reflect onto itself. Does that make sense? Yep. Which of the following functions have inverses? So what's it really asking? Is it 1-to-1 or not? If it is 1-to-1, then it will have an inverse. If it is not 1-to-1, then it will not have an inverse. How can you tell just from coordinates if it's going to be 1-to-1 or not? Let's go back to our visuals, our graphs. All right, it's all about the graphs, man. It's all about the graphs. Oops, and I've lost my. Oh, it was the previous page. Back here. So when we had this one, the horizontal line test, for a value of y, right? These two coordinates, they had the same y value, didn't they? And different x values. So that means you have to look. Did it again. You have to look at your points. Is there any function there that has the same y values with different x values? And if that is, then that's no good. Where have you seen? B. So B would not. Where an inverse? Write down the inverse function. So B doesn't. 3, 2, 2. Looks like the others. Now, how are we going to get?
Just switch the coordinates around.
We have to write down the function. Sketch the graph of, and we're not getting bamboozled by that one. We go, yeah. This is just y equals x squared take 4. And I'd like to think you do not need to go to your calculator for this, do you? Why do we not need to go to our calculator for this? What? It's not exponential. So we know that good old y equals x squared, oh, look at that for smooth curve, is that one. And what does the -4 do? Yeah, it just drops it down. Now remember, your sketches do not have to be to scale, so I'm not counting 4 squares or anything like that, but I am going to make an effort to make it somewhat symmetrical. So there, I just popped the 4, and then we know that this is y equals x squared. Take 4.
To do all 19 questions.
Yep. All 19 questions. It didn't come out. Thank you. Is that okay? Thanks. Thanks, man. So we've sketched that and reflect it. We right, boys? We right? And reflect it in y equals x. So, let's try. Blue and green should never be seen. Oh dear. No, that didn't work. Don't mock me. You try. I gave up on my inverse sketch, right? It doesn't have an inverse because it's got a horizontal line touching twice. Does f with a restricted domain x great... x greater than 0 have an inverse function? Absolutely it does, yes. You guys are annoying me. And by guys, I mean Tyson. Okay, so yes, that bit there does have an inverse. That's what we were talking about before, because it's just going to cut once and you can reflect that in your x-axis, y equals x line. So do you think you can carry on working your way through? We're doing all of these questions. If you see a question and you go, oh my God, this is just irritating, maybe do it and you're getting up to speed and accuracy. Hey Ryan, we're going through and we're finishing that exercise on one-to-one and inverse, but we've just had some people ask some questions about the assignment, so I figured we'd tune you in on that. So 6 was the issue. Talk to me. How to start? Is it how to start? Okay, so given that k is a repeated root, what does that mean, repeated root? Yeah, it's squared. So we've got a couple of things that we can do. You've got options, okay? What's one option that you've told me? You can go x take k squared, and that means you can then, what would have to be in here?
2x squared.
Right, I'm going with, it would have to be linear, and you've already gone above and beyond and said, well, that would be 2x, and then plus or minus something. Now, we can't say b, so you could say c, so you could say plus c, you could say 2x plus, what did we say before? So when I expand this, I'd have k squared, so you could have b over k squared. I think I ignored the fractions this time around, so up to you. What else could you do? Yeah, you could divide through. You could use synthetic division and go k, and we know if it's a root, then this thing here would have to be 0. What else could you do? That's probably about it. I mean, you could say p of k equals 0, but that's not really going to help you with being a double root, is it? Being a repeated root. So that's probably not helpful. Personally, I've done these, so I went, it's very difficult to talk while others are talking. I went with this option. And to make my life easier, I expanded this. So I would make sure that I've got x squared minus 2kx or 2xk, yep, plus k squared times 2x plus c, and then I did the old equate coefficients. Okay, so it's just then going to be a form on algebra. Oh, sorry, I did that when I did my solutions too. Thanks, man.
It's blended in with the bracket.
It's blended in with the bracket. Yeah, okay. Get rid of that.
No,
there we go.
Got what you meant.
I know, but I should do. I'm going to erase that. I'm not going to keep it anyway. So that's how I sort of went. Anything else? Any other question?
Can you do start us off with 7?
7 as so. Lovely. I'm looking at this bit here. If minus 2 plus I root 5 is a 0, what does that then fall into, Karen?
-2 minus I.
Yep, then minus 2 take I root 5 is also a 0. And then what is that falling into? Sum and product, salt and pepper, sum and product. So what should happen is you will have a quadratic from your sum and product. You can see here that this is a degree 4, which means you are going to have another quad. Now, if this one is z squared, blah, 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 then this one would have to be 3z squared, blah, 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 blah. Okay, we've already got a b and an a, so you might have to say plus cz plus possibly d, yeah. But you will have enough information, trust me, when you equate coefficients. But again, this one should have been, if you weren't quite sure, right, this gives it away. Try sum and product. Oh yeah, that's going to give me a quadratic. I've got a quad times something I should be able to get, and you keep going. So if you were just nervous, but you were on the right track, jolly good. Yep, the polynomial is divisible by x take 2, so that bit there, if I was to reword that, I guess I should say x take 2 is a factor. Okay, so what would that you then write after that?
P of 2 equals 0.
Well, yes, I was right. F of 2 equals 0. And of course, the remainder of 6 when divided by x plus 1, P of minus 1 equals, it's frozen on me. Yeah, it's frozen on me though. I'd love to write equals 6, won't let me. Oh, there we go. Equals 6, and then hopefully you can sub it in, away you go. Okay. I have put, and we'll go through it a little bit later on, but I have put, and it's not showing up here. Can people, if tonight, have a look in the one-to-one? I've put some notes. I don't know why it's suddenly not showing. It was showing just before. But put some notes in your OneNote for you to have a peruse of. That's it. So now it showed. Shreya, just so you know, in your OneNote, I just put a couple of summary things, right, for one-to-one functions, a couple of examples, inverse functions, have a perusal. And obviously, if there's stuff there that we haven't done yet, we'll stop. But just some examples that you might find helpful. So don't do the modular stuff yet. Don't do the absolute value. That's for next lesson.